obviously here today. So you're seeing the notes, and I'm going to go through these notes with you. And I'll put some up on the board right here. But basically, what this is, we talk about the constant proportionality. We've been talking about it on Monday and Tuesday that proportional relationships are a constant rate or kind of like a unit rate. Now, what we can do, we can transform this equation. This K just represents our unit rate, okay, or our rate. We can use this rate or unit rate to make an equation out of, which is y equals the rate or unit rate times x. So that will be our equation for these situations. Now, x is an independent, so right here, independent variable, and y is a dependent variable. This means that a change in x will affect the y. And so, for example, a change in number of hours you work would affect the number how much money you get. Okay, the how many pounds of meat do you buy will affect how much you have to pay for the meat. Now that constant of pay per hour is still the same, and the price per pound is still the same. It's just that the x you have to kind of figure out which one is the changing the information, which one is affecting how much you pay or how much you get paid, or how fast you're going or how many hours you drive. So, for example, you're buying New Jersey some Jersey tomatoes that cost £2 for $3.98. So write the equation, the relationship. So we're going to let C equals cost, and we're going to let P equals pounds. And so 398 divided by 2. So our rate is 398 divided by 2. And so C equals 398 divided by 2 times the pounds. Now, we really don't want to keep it as 398 over 2 because it's a rate. So it's best to use the unit rate. And so 398 divided by 2 is going to be $1.99. So $1.99 means cost equals $1.99 per pound. And so that is a much better equation for it than just putting the rate. So our unit rate is that constant of proportionality. That's what they like to call it sometimes, a constant proportionality. $1.99 is that constant proportionality. So here we have another one, candy store. You purchase 5 pounds of candy for $22.45. So in this case, we're still going to have cost, and we're going to have pounds because we have cost per pounds. So our cost proportionality is that rate. So cost, put that marker away. So cost equals $22.45. Remember, money always goes on top. And that's why I say it is 5 pounds. And we have P pounds times pounds. So we want to change that rate into a unit rate. 22.45 divided by 5 is going to give us $4.49. So that means whatever pounds we want, we can know the price of the candy that we are buying. Now, sometimes they put them in equations. Now, we've been doing this yesterday and partly on Monday, is when we're finding the proportional relationship, the rate or unit rate is always constant. And so we can find that also in tables. So we can take, if we know it's a proportional relationship, in this case, we know this one's a proportional relationship. Now, if we didn't know it's a proportional relationship, we needed to do the miles divided by the gallons. Each situation, miles divided by gallons, miles divided by gallons, miles divided by gallons, to make sure that it has the same unit rate. If it's not the same unit rate, it is not proportional. And so that's why they call it, once again, constant proportionality. Is the unit rate the same for all of them? And so if it is, we're good. And so we have to figure out, though, which ones are independent and dependent. And so that's something you got to make sure you're focusing on. Well, miles divided by gallons, miles per gallon. This is one of those things we've talked about with unit rate. So we're going to do miles divided by gallons here in this situation. So you got to be cognizant of that. This won't always be given to you. And so our outcome is always the miles. Okay. So however many gallons we get determines how many miles we can go, right? And so our equation is not going to be C equals and pounds in this case. We're going to have miles. Miles equals, well, 247 divided by 10 is 24.7 times gallons. So miles equals 24.7 times the gallons that we get. So here we go. In this one, this is a question. Write an equation that represents the proportional relationship. The total cost C of grapes. So C is always going to be equals of $1.40 per pound. So this one would be A right there. So it would be A. 71. Write a proportional relationship that represents the proportion. So since we know it's a proportional relationship, we don't have to do the every single one of them in this case. But remember, 5750 divided by 5, 172 divided by 50 divided by 15, and so forth. Remember, money always goes on top. And so we have the cost of the shirts is C equals, well, let's say 5750 divided by 5 shirts. And then S is the number of shirts we buy. So our cost is going to be $11.50 times S. Okay. I'm gonna put a little dot there. I don't really like using S, but that's what our equation would be. So in this case, it would be B. So cost equals 1150 times S. That's how we can get the equation. Now here with a graph, we have to be careful. Okay, we won't write a proportional relationship that represents write an equation that represents the proportional relationship. Now, whenever you're looking at a graph, you want to make sure you do the y coordinate divided by the x coordinate. So remember, this is the x-axis, this is the y-axis. And so we know it's a proportional relationship because it's a straight line and it goes through 0, 0. So what we want to do is we want to pick a point. So I'm going to pick this point right here. I'm going to go left. My y value is 1 and my x value is 3. So that's my rate. Okay. All right. That's my rate. So y equals 1 over 3 times x. Now, you might say, well, Mr. Cunningham, well, why don't we do and divide it? 1 divided by 3, and we will get y equals 0.3 repeating x. Now, the problem with that is you can't put enough decimals in there. So it's best to leave it as a fraction of 1/3. Okay, so whenever you come across like a repeating decimal, go ahead and just leave it as a fraction. Hit that F to D button and go back there. And remember, we can use different points too. We don't have to use the 1, 3, sorry, 3, 1 for the coordinate point. So this was our coordinate point was 3, 1. This coordinate point over here is going to be what 2.5 and 7.5. So 2.5 and 7.5. 2.5 is our y and 7.5 is our x. So our y value and our x value, y, x. So y divided by x is going to be 1/3 or 0.3 repeating, which is going to be A in this case. Here we just have an equation. Write an equation that represents the proportional relationship. You're ordering new menus for your restaurant. So you pay $362.50 for 50 menus. So we know it's going to be cost. We know it's going to be cost. And money always goes on top. We know that. So cost equals $360.50 divided by 50 menus. Now, we're going to want to use M for our menus because the number of menus we buy or order is going to determine how much it's going to cost. And so we can reduce that, we can divide that, and that gives us $7.25, $7.25. So each menu costs $7.25 times the M. So our answer in this one would be D. So write an equation that represents this proportional relationship. Once again, remember, if you're doing this, you always want to make sure you do the, if you don't know it's proportional relationship, divide each one to make sure. Now, here in this case, we have days and hours. And so this one's a little bit different as far as days and hours because here we have kind of time for both of these. And so we're going to have to kind of figure out what generally is our X and our Y. So in this case, maybe the number of days is going to be our x, and our hours are going to be y. And so if we work 17 hours in 2 days, and 25.5 in 3 days, and 34 divided by 4, we just want to make sure that we have a constant relationship. And so 17 divided by 2, 8.5, right? All right, so the hours are going to determine our days. And so 25.5 divided by 3, if we do that, it's 8.5. And all the way through, it's 8.5. And so our days is our x, and our hours is the y. So hours is the outcome, okay, equals 17 over 2 times days. Now, if you'll notice here, notice how the y value, the numbers that we get to the y, is our hours, and then d is days, okay? 2 is the x, and it's right there. So h is 8.5 times d. So the number of hours you should be working is depending on how many days you actually go to work. So you work 8.5-hour shifts. And so if I work 5 days, I know how many I should be working, which is 42.5. If I work 10 days, I know I should work 85 hours. All right, so I know how much that outcome should be. Here we go, we have a word problem. The amount of money Jamie earns is proportional. That just means we're at a constant rate to the number of hours she works. All right. So she earns $60.50 in 5 hours. So we know, all right, how much pay she gets. Okay, so let's say we're going to put money for the amount that it says M for the amount of money. So her money is her outcome, and so money goes on top, 62.50 divided by 5 times the number of hours she works. Now remember, this is a rate. We want it to be a unit rate, which is a constant proportionality, okay, our constant. So money equals, well, it's going to be $12 and let's see here, 62.50 divided by 5, $12.50 for each hour she works. Okay, so Jamie gets $12.50 an hour, and so she knows that, hey, if I work 30 hours, this is what I get paid my money wise. M equals whatever 30 hours of work is. And so she can check that on her pay stub. Now, this one, the number of parts produced by 3 different machines are shown. Okay, so we have the minutes and we have the parts that each one produces for each minute. One of these machines produces parts at a constant rate. Write an equation that can be used for y and used to represent y, the number of parts produced. So parts is our y. So machine Q did 9 parts in 1 minute, 18 parts in 3, and 27 in 9. And so x is the number of minutes. So that means since we're going to be, our y is going to be the parts produced. So we're going to say P for parts produced equals whatever our unit rate is for in minutes. So minutes and then parts produced. So let's look at machine Q. All right, machine Q does 9 in 1 minute. So that means 9 divided by 1 is 9. But then 18 parts. So we have 18 parts in 3 minutes. So 18 divided by 3 is 6. That's not the same unit rate, is it? So it's not constant. And so we have to get rid of that. Machine Q does not work for us. Machine R, let's do that. 8 divided by 1 is 8. 24 divided by 3 is also 8. And then we got to make sure 72 divided by 9 is also 8. So right here, we can go ahead and stop. And machine R is the one that produces at a constant rate. And it produces at a constant rate of 8 parts per minute. So our equation would be P is equal to 8M. So P is equal to 8M. All right, Hayden mixed 6 cups of blue paint and 8 cups of yellow paint to make green paint. Okay, so he's mixing them together. Write an equation that shows the relationship between the number of cups blue paint and the number of cups yellow paint, Y, that are needed to create the same shade of green. The equation should be in the format of B. So blue, so we're saying blue equals, and the amount of blue that we need equals our constant rate of y, yellow. Now, that means yellow is our x and blue is our y. So we're going to take blue paint, which is 6 cups, and we're going to divide it by 8. Okay? Because we have less blue paint than yellow paint. And so if we look at our constant proportionality here, if we take 6 divided by 8, we're going to get 0.75 times y. Now, I kind of don't like decimals. If we don't get a whole number, I kind of like using a fraction, so 3/4. So b equals 3/4 y. And so that means we're going to use a little less than what yellow is, right? So if I say we have 10 cups of yellow, that means we're going to be using 7.5 cups of blue. So that's something that we have to make sure. We're using less blue than yellow to make green. And that's something that's very important to make your ratios are correct. I did work at a paint store. I worked for PPG Industries at Lowe's for a couple of summers when I was teaching. And you have to make sure those ratios are right. Now, the computer does it for you now. You just put the code in, but you got to make sure you have the right base um, gallon. So, like how much white is in a gallon to make a certain color. And those ratios got to be correct. So, understanding graphs of proportions. So, graphs, remember, it has to be proportional relationship. It's got to be a straight line. Okay, it's got to be a straight line and go through the origin 0, 0. So 0, 0 does not matter as far as if it's proportional or not. It's okay to see 0, 0 on a table or on a graph. All right. So once we've determined that, we can now make an equation out of that. So here we go. We have dollars on our y-axis, and x-axis is passengers. And so right here, let's go ahead and set up our equation. We see the y-axis is dollars. And so we're going to put D for dollars, since it's our y-axis. D equals. So I already have D equals. And then P for passengers. I'm going to put P for passengers right here. Now I just got to find the unit rate. And so I can pick a point. All right. I can pick a point. And I know it's a constant. So I can pick whatever point I want. Now this is not read very well. I'm going to say it's like 5 and 2. Okay. And this is maybe 2, 10. It's off a little bit, 10 and 4. So my y-axis is, let's say 5, and my x is 2. It's not in perfect point. For whatever reason, this is not very easy to read. So 5 or 2, or even, now this looks like it's at 9. 9 and then 4. So 2 1/4. So maybe this is 4.5. Yeah, so 4.5 and 2. So if I do 4.5 and 2, if I divide that, so my y is 4.5. So 4.5 divided by 2 is 2.25. And then if I do 9, let's say this is 9 and 4. So 9 divided by 4 is also 2.25. So we have those points, okay? Now remember, if they give you a point, it's okay. So like 5 and so if they give you a coordinate point, it would be 2. Get a better marker here. My markers are not doing very good anymore. I've had these for like a year. So 2, 5. That'd be a corner point. Remember, x, y, and a corner point first. So y, 5/2. The other point is 4 for our x and 9 for our y. And so you have x and y. Now remember, you can also just use the graph. I like using the graph a lot of time, just kind of figuring out what the points are. And so 9/4, 5/2. We divide those. We end up getting D equals 2.25p. So obviously you can't get 2.25 passengers, but this is an average, so it's not going to be perfect. So 2.25p here. So we're going to change that to 2.25. So we're charging each passenger $2.25. Okay, to board the train. Okay, the ride or whatever it is, the jitneys. So $2.25 for each passenger that wants to ride. Here we have Mark drives to work each day. His gas mileage is shown in the graph. What is the unit rate? What does it represent? Now, we're not answering all these questions, but look at our y-axis. Our y-axis is miles, and our x-axis is gallons. So that means our y-axis is miles. So we're going to put miles, M equals, and then gallons, G. I'm going to pick my point. I only have 1 point. They're going to give me 1 point. Let's say it's 150 and 5. So 150 and 5. So that's our rate. We divide that by 5, and M equals 30 Gs. So our unit rate is 30 miles per gallon. Right? Jasmine gets paid for every dog that she walks. So once again, money's on top. It's our y-axis, and the number of dogs she walks. So money dollars equals, so since these are both, I'm going to put money for M. They're both dogs, and so D, dollars and dogs. I'll put D for dogs, and then I'm going to pick my points. So if I do 8 dogs, let's say it's 8 dogs, I get 2. Remember, they might give you a coordinate points like 2, comma 8, and it might give you 4, comma 16. So our y here is what? We'll say it's 16 and 4. Okay. I promise you on your work it's going to be a little more clearer, but this is proportional relation. It goes through 0, 0 straight lines. 16 divided by 4 and 8 divided by 2. So 8 divided by 2 here is 4. So money, we get $4 per dog. Okay, so $4 per dog would be our equation, and we'd be good with that. All right, now Mary drives a bus. Her rate is shown in the graph. What is the unit rate? What does it represent? So our y-axis is P, and ours is our x. So P equals whatever their unit rate is times h. Now this one, we're going to find a point. They don't give us a point. So we just got to find out. Now, the unit rate would be right here at 1. So a 1 hour would be unit rate. So if I go up here, let's say it's maybe 15 people an hour. Okay, well, it's just 2. Be close. Okay, so my unit rate would be at this point of 1:15. So if I just find that point of where 1 is for the x-axis, there's my unit rate. So I can say it's 15 people per hour, 15 over 1, or if it's 15 each hour, there's my unit rate. All right, last slide here. This graph shows the relationship between the pounds of cheese bought at a deli and the cost. So right now, we know right away, cost is our C. It's our y-axis. And then P for pounds. So we got to find the unit rate. Select each statement about the graph that is true. So let's see here. 0, 0, so that's the origin. Shows that it costs $0 for 0 pounds of cheese. Okay, that one is true. The first one's true. Now, if we go to 25, so 0.25 is 1. So this is the x. So 0.25 would be right here, and then 1 right here for a y. So if you buy a quarter pound of cheese, it's going to cost $1. So does that make sense? Does that make sense? So 25, a quarter of a pound is $1. This is saying that it actually costs 25 cents for 1 pound. No, that doesn't cost 25 cents. 25 cents is like right down here somewhere, and it's really, really small. So that one would not be the point half, 0.52 shows that a half pound of cheese costs $2. So if we go half pound and the 2, yes, a half pound costs $2. So A and C work so far. The 0.14 shows the cost of $4 for 1 pound of cheese. So right here, this is 1 pound and then $4. So there, right there is our unit rate. Right here, it has one, a denominator of 1. So 4 over 1, so $4 for 1 pound of cheese. There is our unit rate. So 4P. So A, C, and D work. And then the 0.28 shows that 8 pounds of cheese. Whoa, 8 pounds of cheese does not cost $2. I mean, if we got 2 pounds of cheese and it costs $4, all right, or sorry, 1 pound of cheese costs $4, then there's no way 8 pounds of cheese costs $2, right? Right. And so this is an old part question. This is a non-calculator question. You don't need to use a calculator on this one. But that's it for notes, guys. I hope to see you. I will see you tomorrow. And complete your work and have a good rest of your day. Bye.